Good morning. Today we are going to see the questions which may asked in your oral. Now we will start with unit. Yesterday I already sent on your group some videos which are related with your practical works. Again I will prepare some videos. Parallelly we will go with what will be the possibility that questions will be asked in orals from your theory part. Now we have first unit if we will go. So we have first unit that is stress. Now definition of stress, you should be very clear. We know it. This is resistance upon area. Already we mentioned it. Resistance upon area. Now he may ask, we may have this definition as load upon area. When we will go for this definition, so this is applicable only for elastic materials. Elastic materials. Now he may ask what will be different types of materials. So we have materials three types. Materials. So we have elastic. Then we have elastoplastic. Elastoplastic. And third we have plastic. Third we have plastic. Now what is difference between these two? So in this, resistance equal to load, and therefore we can use stress equal to resistance upon area, or we can use load upon area. If we will go elastoplastic, so some part of the load is utilized for plastic deformation, and therefore we are not going to regain original shape and size, and therefore your resistance less than load, and therefore in elastoplastic you have to use stress equal to resistance upon area. Now in plastic, whatever deformation you get, that deformation is permanent. Permanent deformation. No regain. And here we are going to say my resistance is 0. Resistance equal to 0. And therefore, in plastic bodies, stress is always equal to 0. You have to keep in mind these three definitions which are most important related with your material. So we have these three definitions. So these are related with your materials. This is first part. Now we have second part, that is the unit of stress. So we have unit. Always keep in mind, I always mention in the class also, you have to derive the units. So we have stress. Stress equal to, you can write R upon A, or you can write P upon A. Unit of P is Newton and unit of A is per millimeter square. Now we can write unit of stress as Pascal, PA, denoted by Pascal. What is unit of Pascal? So we have 1 Pascal, that is equal to 1 Newton per meter square. Again, this is most important. And from this, you can convert the unit. If anyone asks, what is 1 MPa? So if I will write 1 MPa, What is M? Now already I mentioned, we should know that. I will write in next slide. So MPa, M we have 10 raised to 6 PA. And PA we know Newton per meter square. Convert meter square into millimeter square. So we have Newton and meter square, that is equal to 10 raised to 6 millimeter square. And from this we will get 1 MPa equal to 1 Newton per mm square. Conversion, you should be in position to explain. If asked what is 1 GPa relation, so we have G 10 raised to 9 PA. PA we have Newton per meter square, and then we can have 10 raised to 9 Newton divided by 10 raised to 6 millimeter square. And we will get this equal to 10 raised to 3 Newton per mm square. So we have 1 GPa, that is equal to 10 raised to 3 Newton per mm square. So suffixes, if you will be asked, then already I mentioned it. तुम गए तो मुझे कौन है, डैड से मैं यू नहीं पढ़ सकता. And then we have 10 raised to 12, 10 raised to 9, 10 raised to 6, 10 raised to 3, 10 raised to 2, 10 raised to 1, 10 raised to minus 1. Dad say my we have m. 10 raised to minus 2, 10 raised to minus 3. Mu we have 10 raised to minus 6. And we have 10 raised to minus 9. And p we have 10 raised to minus 12. So you have to keep in mind only one statement. तुम गए तो मुझे कौन है, dad. So here we have is afraid to say. So dad say मैं you नहीं पढ़ सकता. You नहीं. So you नहीं पढ़ सकता. And that we have to keep in mind for these suffixes. So unit we have stress. Now stress we have how many types, and for all stress unit is same, Newton per mm square. So we have normal stress, in which we have two types, that is tensile stress and then we have compressive stress. Compressive stress. Unit we have same, again I am mentioning it. Then we have another type, that is shear stress. Same unit. Then we have hydrostatic stress, which we are using. Hydrostatic stress. Hydrostatic stress means we have same stress along all sides. So, and that where it will happen if any body is at a higher depth in water, then only we have hydrostatic stress. Normal stress, we have Young's modulus. Young's modulus by using normal stress. Shear stress, we have shear modulus or modulus of rigidity. Shear modulus or modulus of rigidity. And then third, hydrostatic stress, related with bulk modulus. So here we have formula delta L equal to PL upon AE. This also you have to keep in mind. This will gives you linear strain. Linear strain. So stress directly proportional to strain in all. Sigma directly proportional to epsilon. Sigma is equal to E epsilon. Tau directly proportional to G. Sorry. Tau directly proportional to gamma. Shear stress, shear strain. So tau is equal to G gamma. Here we have bulk modulus. In bulk modulus, we are going to say that is stress directly proportional to strain. In this, we are not going to be exactly in this fashion. Here we have volumetric stress and volumetric strain. So volumetric stress that is equal to, then denoted by K, volumetric strain. So volumetric stress is directly proportional to volumetric strain. And then we have this value. Volumetric strain, we have change in volume upon original volume. So because we have strain that is change in dimension. Here we have strain, how now that we will see in the next slide. So we are in this fashion. Here this is important one. So strain. What is definition of strain? Change in dimension. Change in dimension upon original dimension. Change in dimension upon original dimension. What will be unit of this? So we do not have no unit, unitless, because dimension of length we have millimeter and original dimension that is also millimeter. So we do not have any unit. So unitless. What is the relationship between these three? So we have E is equal to 2G in bracket 1 plus mu. Then we have E is equal to 3K in bracket 1 minus 2 mu. We actually should know the relationship between all the three. So relationship between E, G, and K, that also you know, we have this relationship that is E equal to, or that can be written, just a minute. So we have this will be E equal to 9 kg upon 9 kg upon G plus 3K. Just I am saying this. First two, these we are using always, that is 3K in bracket 1 minus 2 mu, and unit of all these moduli, we have Newton per millimeter square, E, K, and G. We have unit Newton per mm square. So these things we know. So, and then only we can have this. So then we have lateral strain. Strain we have shear and lateral. So shear strain, if you will see, we are in this fashion. And if you apply stress on this, then it will be in this fashion. And then whatever this phi, that will be your shear strength. Maybe phi or maybe gamma. Now we have that is lateral strain. What is difference? This is most important again. Now lateral strain means if I will consider a body, so we have in this fashion, and then we have force P over here. And stress, normal stress we have on this area. So we have this cross section area. He may ask, you have given L, B, and this is D. Find stress. So how we will get sigma? So area we have to consider which is perpendicular to this. This length is along the force. That should not be considered. And we have sigma is equal to P upon BD. So this will be lateral stress. And how we will get strain? So we have linear strain that is along the length delta L equal to strain. We have delta L that is equal to original length minus delta L is length after deformation minus original length. Length after deformation minus original length. Minus original length. Then we have strain. Delta L upon L means change in length upon original length. So what is lateral strain? So we have lateral strain that is equal to mu into linear strain. Mu into linear strain. Or you can say Poisson's ratio. So we have Poisson's ratio. Poisson's ratio. This is equal to mu, which is equal to lateral strain upon linear strain. Lateral strain upon linear strain. These are important things which I am explaining. And value generally from 0.25 to 0.3. So these are the questions which we have that is related with your stress, strain, and likewise. So now for this first part, we will stop here only. Then we will go second part, that is temperature stresses. You write it and then you will be in position to answer the question. So now I will stop here only. Remaining part we will see in the next lecture. Thank you.